All right, so when you hear the word evolution, what pops into your head? Probably something like a cheetah chasing down its prey, or maybe those famous giraffes with super long necks, right? The strongest, the fastest. But what if I told you that one of the biggest drivers of evolution has absolutely nothing to do with being better? What if it's all just pure luck? I mean, we've all had that phrase drilled into our heads, haven't we? Survival of the fittest. It paints this picture of a constant, brutal battle where only the absolute best adapted creatures get to pass on their genes. But is that really the whole story? Let's dig into that a little bit because I think we can challenge that. See, sometimes evolution isn't a race. It's not a fight at all. It's more like a game of chance, like rolling the dice. And in this game, pure luck can decide who makes it and who doesn't, and it has nothing to do with how fit you are. And this other engine of evolution, this random, unpredictable force, it actually has a name. We call it genetic drift. And while it might be the lesser-known cousin to natural selection, trust me, it's just as important. Okay, so what in the world is it? Well, to put it simply, genetic drift is all about random changes in how common certain gene versions, scientists call them alleles, are in a population over time. And I can't stress this enough, the key word, the most important word here is random. And that's really the fundamental difference. Think of it this way. Natural selection is all about helpful traits, right? Traits that help something survive, find a mate, and have babies. It's adaptive. Genetic drift, though, it's driven purely by chance. It couldn't care less if a trait is good, bad, or totally neutral. Okay, I know that might still sound a little academic, a little abstract, so to make this super clear, let's just tell a story. Let's see how this whole roll of the dice thing actually plays out. So, I want you to picture a little group of rabbits. Just 10 of them, they're all on their own in a little isolated meadow. And pay close attention to that number, 10. The small size of this group is going to be super important in just a minute. Now, in our little starting population, the genes for fur color are split right down the middle. You got 5 rabbits with the gene for white fur and 5 with the gene for brown fur. A perfect 50-50 split. And let's say there are no hawks, no foxes, nothing. So being brown or being white doesn't help you hide any better. The environment is totally neutral. Now, just by pure chance, it just so happens that for whatever reason, only the white-furred rabbits managed to have babies this year. That's it. It's not because they were better looking or healthier. It was just a fluke. Maybe the brown rabbits were all hanging out on the wrong side of the meadow that day. Who knows? It was random. And look what happens next. Because of that one single random event, the next generation is born. And it's all white rabbits. The gene for brown fur could be gone. Just poof, vanished. The whole genetic makeup of this little population has been turned on its head. And right there, in that little meadow, that is genetic drift in a nutshell. The population evolved, right? Its genetics changed from one generation to the next. But not because white fur was some kind of super trait. Nope. It was just luck. That's the power of chance for you. Okay, so a cute story about rabbits is one thing. But what about the real world? Why does any of this matter? What's the impact of this random process on the grand stage of evolution? And you might be thinking, hold on a second. It's a really good question, actually. If this whole drift thing doesn't make animals better for their environment, how could it even be evolution? It kind of feels like it goes against the very definition of it. Well, the key is to remember what evolution really is at its most basic level. It's just any change in the genes of a population over generations. That's it. It doesn't matter if the change is good, bad, or makes no difference at all. If the genes change, it's evolution. And genetic drift definitely causes change. Okay, here's a crucial point, though. Genetic drift is happening all the time in every population. But its effects are way, way more powerful in small populations. Just think about our 10 rabbits. Losing the 5 brown ones was a massive deal. It changed everything. And this is exactly why people working to save endangered species get so worried. A tiny population can lose super important genetic traits just through bad luck. Yeah, in that tiny group, one random event can totally wipe out a gene. But now, imagine a population of 1,000,000 rabbits. If a handful of them don't have kids by chance, who cares? It's a statistical blip. It's not going to make a dent in the overall gene pool. The sheer numbers just kind of smooth out the effects of randomness. All right, so let's just nail down the main points here so we're all on the same page. Number one, genetic drift is driven by random events, pure chance. Number two, it is a real, bona fide engine of evolution. Three, it is not about being better or more adapted. And four, and this is the big one, it's way more powerful in small populations. So when you zoom out, you start to see that the story of evolution isn't just this grand epic of struggle and victory. It's not only about survival of the fittest. It's also a story of luck. It's about random chances, lucky breaks, and totally unpredictable twists of fate.
And that kind of leaves us with this big, mind-bending question, doesn't it? If chance plays such a huge role, what does that say about the future of life on Earth? It means the future probably isn't some straight line towards perfection. It's more like a random, unpredictable, and, frankly, much more interesting journey.